Okay, algebra video 2 on piecewise functions. Example 2, it says a piecewise function f is shown to the right. It's to the left, actually. Use function notation to describe the function and determine the x and y intercepts. Ooh. Okay, so to do this, right, we are going to first find the two pieces. Okay, so we know that piece 1 is over here, and we're going to say piece 2 is over here. And this is our point that kind of breaks them apart. So we know that x equals 1 is like that break apart point, right? So that number 1 is going to be in our domains when we write our function. Okay, so these are both parts of lines. So the first thing I want to do is I want to find the slope, right? So let's find the slope of line 1. Let's go from -3, 2 to 1, 4. We're going to go up 2 and right 4. So remember, slope is rise over run. So I went up 2 and right 4. That's a slope of 1/2. Okay, and now we're going to use the point 1, 4. You could also use -3, -2, but I don't want to use the negative numbers as an x and y value. And we're going to use slope-intercept form, which is y equals mx plus b. We're going to plug in our m, our x, and our y and solve for our b. So your y value is 4, your m value is 1/2, your x value is 1, and then you have your b value. So this is 4 equals 1/2 times 1 is 1/2. And then you're going to subtract 1/2 on both sides. So this is 4, which is 4 over 1. And you can just use a calculator, right? So 4 over 1 minus 1/2. I'll do it by hand. So 4 over 1 can be made into 8 over 2, right? 8 divided by 2 is still 4. And now they have like denominators. So 8 minus 1 is 7 over 2. There's your b value. So I'm going to write my piecewise defined function down here, f of x equals, this is going to be part 1, so that's going to be mx, so 1/2 x, and then plus your b value. And I'm going to define that over the interval when x is less than or equal to 1, not -1, 1, because that's the left side of the graph, right? And because these two pieces touch, I could have put the equal to with either the top domain or the bottom domain. It doesn't matter. I'm going to put it with the top. And again, they like to put this word if x is less than or equal to 1. Okay, and then step 2, let's find the other linear equation. So I'm going to count the slope from 1, 4 to 4, -2. We're going to go down 1, 2, 3, 4, 5, 6, go down 6, and then right 1, 2, 3, and then right 3. So the slope here is down 6 and right 3, which is a slope of -2. We are again going to use the point 1, 4 as our x, y in slope-intercept form. And now we'll do y equals our m times our x plus b. So this is 4 equals -2 plus b. I'm going to add 2 to both sides. 4 plus 2 is 6. Our 6 is what our b is. So the second function is going to be y equals -2x plus 6. And that is if x is greater than 1. That's the right side of the graph. And now we're going to find our intercepts. So if you look over here, let's do the x-intercepts first. So for the x-intercepts, there's going to be one over here that we cannot see, and then there's one right here. So I think I can read the one right here, right? 1, 2, 3. So that x-intercept is 3, 0. So I got that from the graph. But for this x-intercept, what I really have to do is I have to plug in 0 for y. So if you're finding your x-intercept, your 0 is y. I'm going to take this left equation, equation number 1, and plug in 0 for y and solve for x. So I'm going to do it right here. I know it's kind of squishing it. So we're going to go, so y equals 1/2 x plus 7/2. So we're going to do 0 equals 1/2 x plus 7/2. First of all, I don't like these halves. I'm going to multiply everything by 2 to get rid of them. So this is 0 equals half of 2 is just 1, x. And then when you multiply this by 2, the 2's cancel and you actually get plus 7. And then I'm going to subtract 7 on both sides, and -7 equals your x. So this x-intercept is actually -7, 0. Okay? And that's going to go here. Okay, and then to find my y-intercept, I believe it's right here, right? That's on the first graph, so it's the y-intercept of your first graph, which is right there at 7/2. So your y-intercept is 0, 7/2, and there's your intercepts. So we have our function down here, our piecewise function, and then we have our intercepts. And then last but not least is the domain and range. So for this graph, the domain is going to be all real numbers because of the arrows. Again, that is from negative infinity to infinity. And then the range, this time, you have a high y value, or a maximum value at 4. So now, and it's a solid dot, so we can equal 4, so it's going to be y is less than or equal to 4. And that would be, since we're going down, right, less than, that's negative infinity to 4, our highest value. And we're going to put a bracket around that 4 because we can equal 4. Okay. And then last but not least, let's do some evaluating. Okay? Alright, so example 3 says, for the piecewise linear function, find f of -4, f of -2, and f of 0. So first thing is first, we have to look at our domain and see which part. Should we use part 1 or part 2 to evaluate each of these values? So x is -4 here, right? So these are all x values. So -4 is less than -2. So we're going to plug this -4 into the first one. So I'm going to do f of -4 equals, and I'm going to plug into this first equation, 3 times -4. And 3 times -4 is -12. So f of -4 equals -12, which means that the point on the piecewise function will be -4, -12. All right, number 2 is -2. Well, -2 is equal to -2, so again, we're going to do the first graph, the first function as well. So f of -2 equals 3 times -2, and that's -6. So f of -2 on our graph equals -6, which would be represented by the point -2, -6. And then last but not least, the third one. So when x is 0, well, 0 is greater than -2, right? I know it's weird, but it's greater. So that means we're going to use the second equation. So f of 0 equals, this would be 0 minus 4. And 0 minus 4 is -4. So f of 0 equals -4, which would be the point 0, -4, which would actually be one of our y-intercepts if that, because x is 0. So that's just a little bonus added information there. And there's how you evaluate functions, piecewise functions. All right, so thanks for watching, and good luck in class.